In this lesson, we will look at Unit 7, Section 7.5, using an elimination strategy to solve a system of linear equations. In this lesson, you will learn how to determine and verify the solution of a system of linear equations algebraically, and then how to solve linear systems of equations by using the elimination strategy. In the previous lesson, we discussed how to use the substitution strategy, and that one is more efficient to use when we have a term with a coefficient of 1. Now we're going to look at the elimination strategy more closely. So elimination may be more efficient than substitution if the variable in both equations have the same or opposite coefficient. You have the option to add or subtract the equations to eliminate a variable. If the coefficients of the like terms are different, create an equivalent linear system by multiplying one or both equations by a constant in order to make the two like terms equal or opposite. So what all of this means, when you're using the elimination method, you're going to be given a linear system of two equations. You need to eliminate either the x variable first or the y variable. And in order to do this, you need to make those variables have the same coefficient, where you can add and subtract in order to eliminate that variable. Once one of the variables are eliminated, then you're left with just one variable to solve in an algebraic way. We're going to look at this now. So to solve the linear system using elimination, we are given the system 2x plus 7y equals 24, and 3x subtract 2y equals negative 4. So we need to look at it. Very different than substitution. We're not actually going to substitute anything at the beginning. We're going to try to eliminate a variable, either x or y. So what I did here, I looked at it 2 and 3, the coefficients for x. I always start off with the left-hand side and then work my way across the equations. So I need to find a common factor between 2 and 3. And I found that to be 6. So my top equation, 2x plus 7y equals 24, I multiplied that by 3. And my second equation, 3x subtract 2y equals negative 4, I multiplied that by 2. When you're multiplying to get the coefficients the same, it is important to notice that you have to multiply each term by that number or by that factor, because it has to be multiplied all the way across and not just that variable of x. When we do that, we have a positive 6x and a positive 6x. In order to eliminate, we need to add or subtract. If I add those two terms, I'm going to get 12x. That is not correct, because that's not going to eliminate that variable of x. So we need to subtract. When we do that, 6x subtract 6x is going to give us 0, and that's exactly what we want, a 0x. So then we have 21y subtract a negative 4y, which will give us 25y. 72 subtract a negative 8 will result in 80. Then we're going to divide both sides by 25, and y will equal 3 decimal 2. Now that we have our y found, our solution for y, we're going to choose either the top equation or the second equation, and we're going to substitute that solution 3.2 in for y. So I chose my original top equation, which is fine. You could choose the top or the bottom. So you have 2x plus 7 times 3 decimal 2 equals 24. 2x plus 22 decimal 4 equals 24. I'm going to subtract 22.4 on both sides, resulting in 2x equals 1.6. Dividing by 2 on both sides, x equals 0 decimal 8. My solution, therefore, will be 0 decimal 8 and 3 decimal 2. To verify my solution, I can substitute 0.8 and 3.2 into both equations to ensure that the left-hand side equals the right-hand side. And that is always a good thing to do to make sure your solution is verified. If not, you will finish the question and you won't know if that will be the correct solution or not. If you didn't want to substitute it back in, you could graph the two equations to find the point of intersection. In summary, when we have to solve using substitution or elimination, it is a good thing to look at your equations that are given. If you have a term or the coefficient is 1, substitution would be the most efficient method to use. However, elimination can be used in all cases. Sometimes this comes down to preference and which one you would like to use. So as you can see in the summary table on the left-hand side, we have 3 different ways to solve linear systems. We can solve by graphing, or you can use a graphing software or calculator, or using grid paper when you do it by hand. There's solving by substitution, solving by elimination. No matter what method you choose, it is a great idea to verify the solution. If you're going to use the substitution or the elimination method, you can substitute for x and y in each equation to check that the values satisfy both equations. And by doing this, you're checking to see if the left-hand side equals the right-hand side. And if your solutions actually do satisfy your equations, then you know for sure that your solution is correct. Also, keep it in mind that when you solve by graphing, you will only get an estimation for your solution. It can be very difficult to read off the graph in an accurate way.